discuss about the Reynolds transport theorem. Reynolds transport theorem. I am not going into the derivation and details of how it is been derived. Uh, I will just tell about its basic use in fluid mechanics. So first I will like to write its basic statement. dB by dt of a system at a specific time t is equals to d by dt integral control volume rho v dv plus integral over the control surface rho b v relative dot n unit vector into dA. So this is the statement of Reynolds transport theorem. So first, before analyzing it, first, what is its purpose? If we want to analyze any fluid flow, then we should remind this thing that we always take some control volume as our area of concern. So while taking a control volume, we know that from control volume the mass identity changes. Therefore, the basic principles such as Newton law, second law, and these type of principles are not valid for the control volume if we apply it in a direct way. But if we want to apply these laws, then we have to convert the system approach from control volume approach. So basically, Reynolds transport theorem converts these laws and these type of interpretation from system language to control volume language. So B is representing any extensive property of a system at a particular time t, and this change with respect to time of any extensive property of a system at respective time t will be equal to the time rate of change of the property within the control volume plus the net efflux of that property from the control volume. So this is the time rate of change of a property within control volume, and this is the net efflux from the control volume, from control surface of the control volume, because as we know that if we let's suppose this is the control volume we have taken, and the whole surface is regarded as the control surface. This whole surface is the control surface, and the whole volume is known as the control volume. So it should be noted that this velocity is relative velocity, means to say that this velocity, if I would write it in a general way, that this velocity vr is equals to v minus vcs if our control volume is a deforming one. This this velocity is relative with respect to the control surface, and if we write this velocity for a control volume which is deforming, so first we will discuss about the types of control volumes. So first we have deforming and fixed control volume. It means that its shape is changing but it is fixed, means that its velocity is zero. Secondly, we have non-deforming and fixed volume. It means that its shape is also not changing and its velocity is also zero. Third, this is mean of deforming and fixed. Thirdly, we have inertial and non-inertial inertial control volume. It means that if for inertial, our velocity will be constant, and for non-inertial, velocity is not constant. So in control, here Vr is the relative velocity, means that this velocity is relative to the control surface, means that we have a reference system attached with the control surface or control volume, and this velocity will be measured with respect to that frame of reference. But here the parameters dB, it will be decided for which property we are concerning, that frame of reference which we uh, referred to the property B. Means to say that if we want to apply B for momentum conservation equation, and we will put B is equals to mv, then this m from Newton's second law, which is applicable for inertial frame of reference only, this V should be from a fixed frame of reference, which should be at absolute rest. So if we want to apply Reynolds transport theorem on different properties like energy, mass and momentum, we will discuss it further in detail. Thank you very much.